for some reason, I'm the chosen one. Maybe it's because I gave a stupid statement in the papers this week. But this week, our episode is going to be about basically nothing and everything, and is going to be related to the news. One of the main ones is going to be Amazon and the corresponding fail. So let's roll the intro, and then let's have a little bit of fun. Okay, Mr. Tired One, what's up?
I'm less inclined today to talk because I'm both tired and at the same time my throat is gone once again. So I have that going on for me. But let's start with you. That wasn't a stupid thing in the newspapers. You just mentioned the obvious. When some online service breaks, it's usually DNS. When a telco breaks, it's usually BGP.
Oh man, I remember we had. I mean, over the years we had so many different, characters in terms of students. And one of the generations has really stuck with me. It was during the COVID era that we hung out a little bit more. And we have one of the colleagues who used to work for us as an IT guy, and then switched and went to Amazon and whatnot. And then the other one as well went to some other company and whatnot. And one of them is always telling hi to us when he sees us or hears from us by saying it's always DNS.
Yes, and I must say that I'm the one responsible because I actually use that as the avatar for the server.
Yes, I know. And he took it to heart. And also, I had more than a few chats with him after what used to be your, lab work exercises. And he was always trying to debug why his lab A and lab B and C and D and EFG and all the letters of the alphabet, both on the Microsoft and the Linux course, don't work. And it was absolutely every single time that it turned out to be DNS.
But the thing is that it's incredibly serious when uh, you regard that we have thought a lot of people about high availability, failover clustering, always available services, and so on and so on. And then a single DNS entry can turn off a single region with a single database API, and then half of the internet breaks.
Hmm.
And I must say that I'm a little bit puzzled because it's not that Amazon has quite a few different regions available. And this was one of the regions, and it was one database in one of the regions. So basically, DynamoDB instance in the region that broke, or it didn't break. It basically ceased to exist, or ceased to be available to anybody. And what happened then is that a lot of the things broke. I created, or I was trying to find the partial list of everything that broke, and I'm going to go through some of the important services and some of the less important services.
Take it slow.
Because what I wanted to do is I wanted to point out how stupid the internet has become.
Hmm.
So let's start for the most obvious and most important ones, and let's start with the biggest ones. So obviously, Amazon broke.
I actually, for the first time in many, many weeks, did not connect to Amazon 2 days ago when that happened.
Yes, you anyways, you couldn't, so that's fine.
Yeah.
Then of the major services, both Hulu and Spotify broke. Spotify was broken a little bit, but Hulu was broken a lot, from what I hear. The thing is that the problem is that people from Europe didn't make that much of a fuss.
Hmm.
People in the States made a big problem out of it because I haven't seen anybody having problems with, I don't know, Snapchat going off or Roblox going off, because people said, okay, it is going to come back up, nobody cares, and let's continue living.
Hmm.
For some reasons, people in the United States completely lost their minds, and
Okay.
I don't understand why this is such a big problem. So
Okay.
let's go through Amazon, Venmo payments,
Mhm.
Hulu streaming, Snapchat, Roblox gaming, Coinbase crypto exchange, Zoom. Then some interesting players like Lloyd Bank,
Mhm.
gov.uk, so government websites and so on. But I'm more
Netflix.
interested in things that people actually cannot stop talking about, although either they don't use the service or the service itself doesn't make any sense.
Okay.
For example, do you know what is 8 hours?
Standard working day.
No, it's a smart bed company. So you can buy a bed that is going to be obviously connected to the internet, and it regulates your body temperature by
Oh,
cooling
okay.
or heating the bed while you sleep.
Okay. I
So it is
actually heard
trying to.
about the concept, but not about the company.
So yes, so there is a company that does this. But the thing is that when the beds lost connectivity, they stuck in whatever state they were
They
in.
were in. That's
So
awesome.
people started to complain that the beds were too hot, they were too cold, they didn't behave. There was a guy that said that his bed overheated,
Hmm.
and my obvious question is, okay, if any device in your home is overheating, why don't you just plug it out of the
Out.
socket?
Yes. My my
So
first thought.
just turn it off. So this is one of the things. Ring doorbells.
Yes.
The doorbell stopped letting. The doorbell stopped working.
Your
I
too.
have a I have a ring doorbell. I don't know if somebody was trying to get in because obviously it didn't ring. So, but this is one of those things when it's actually getting insanely stupid when there is no local connectivity available for any of the services. So you have a doorbell connected to your Wi-Fi. You have a ring chime. It's called a chime. So basically a door ringer that is also connected to your Wi-Fi, but they cannot talk to each other in any other way of through the Amazon's web services.
Hmm.
Now, Fortnite, okay, nobody cares. Tidal, even
Nobody
even
cares,
more
right?
people, more people don't care. Duolingo,
Hmm.
Canva, Pokemon Go, Strava.
Hmm.
So fitness influencers were offline, and of all the other things, McDonald's app.
I didn't think you. I don't think you mentioned Netflix, by the way.
Um, but I'm not interested in mentioning the service like that because most of the major streaming services were in some way or form affected by this thing. So both Hulu, both Netflix, both Amazon Prime. Um, I don't know about Disney Plus. Probably yes. I didn't check
Hmm.
because the list is huge, basically. And the thing that is bothering me is why was there no failover to any of the other regions? How did we come to a point where there is a single point of failure in a single database instance?
And this is what the bulk of my statement for the local paper was about, or for the local
No, no, no.
website.
I'm just preparing the stage for you.
You don't have to really. And for first time ever, when I was issuing a statement, which I was asked to do, I really tried hard to be short. So I got, I think, 6 questions. Uh, 5 questions were answered in 3 sentences, and one of them took six. I was trying to be as short and simple as possible. The problem that I see now, and I think I've been harping about this one for many, many years. This is one of my primary beefs with the idea of cloud altogether, and it has been from the start. If I can expand on your question, the question that is exactly like yours, but in an expanded format, is like this: how did we reach a point in the development of the modern world in which every single fucking, sorry to swear, application, streaming platform, or whatnot is dependent on a single cloud provider and a single region of a single data center? I don't understand that. That's
Even
just
worse, on a single database.
service. Yeah, yeah.
But the database service didn't work. But the thing that bothers me is that even if you count out all the stupid reasons why this is so. One of the reasons being that East 1 is one of the default regions for most of the developers. So they actually don't know how to switch away from the default region. If you, ignore the actual thing where Amazon CloudFront completely went down because Amazon itself has a problem with dependency on that particular database.
Mhm.
Um, the thing that I want to know is what happened to the redundancy? Why is the redundancy not redundant?
Because there is none.
Yes, obviously there is no redundancy, but I was promised redundancy
It's not your
and
service that
redundancy.
failed,
No,
luckily
no,
for
but
you.
the promise is also failed. But the thing is that we teach people on the second class in the university, or the second year of the university, how to provide redundant services. What
Yeah,
happened? The whole thing about Amazon is uh, was the idea of redundancy, having multiple data centers, multiple locations, multiple everything.
multiple clouds, if you ask me as well.
Okay,
Different
but
clouds.
what actually inspired, what was inspiring about Amazon going down was the thing that I must say that I like the most, and this was the jokes about Amazon.
Okay.
One of the most the jokes that I liked the most was the one about the hybrid cloud. I already sent it to you. What is the definition of hybrid cloud nowadays?
What?
You use Azure to authorize AWS because this is what people are actually doing.
Yes, I have that as well.
I know everybody does because Amazon, for
Enter
some
ID.
reason, is the go-to when you need to provision a service. And then people with a heavy heart say, "Okay, we're just going to provide the authentication and authorization part in the whatever the cloud is, or either Google or Azure, usually Azure."
Mhm.
And mostly because they are too lazy to do anything else for the users that are using Office 365. So what is actually happening is that we have reached a point where we are telling each other that there is a redundancy available or the hybrid cloud is available, but we are still committed to using Office 365 from the Azure and using everything else from the AWS with a distinct thing that we are sometimes using Google services from the Google Cloud itself. But all the people that I know, when they need to instance VM or do something else, they're usually using AWS with all these problems.
Yeah, I don't.
Okay, but you are not common people. You're just, I don't know, a guy.
No, actually, my reason is much more philosophical, if I can be honest. It's not that I dislike AWS. I dislike it as much as any other cloud provider and like it as much as any other. I don't care. The fact of the matter is that Amazon, for years, this is purely subjective what I'm talking about. It's the I thing, it's the UI thing, and the design thing. The way in which they present information in AWS UIs is super user unfriendly to me, especially as an administrator. And I do have an environment there that's running some workloads, not a lot. And for me, as much as as much as as much as the chaos that Azure is with portals and everything else, I usually find things a little bit easier there and configure them in a little bit more straightforward fashion. That's first thing, and the second thing, if I'm honest, Microsoft for the first at least 10 years of Azure, because I've been a Microsoft trainer for many moons now, has provided us with some extra credits to use to use Azure for free, so I always had a chance to work with it a little bit more. I got more into AWS after I signed us in the Azure in the AWS Academy program, which, as I'm sure you remember, was a little bit more recent of an addition to our stack. So it's a subjective slash experience thing. If I need to do something, most of the customers that I work for, they have an Azure tenant already, less so in AWS. There are some subtle differences in pricing for the services that they require. That's why, and not it's not a religious discussion or something like that. So for me, AWS is less of a problem. But a lot of times, and yesterday this was, sorry, 2 days ago this was the case. I do have quite a few DNS zones in Route 53.
Yes, and this is one of those problems because for the redundancy of DNS, people are usually using AWS because it actually proves to be the best service, even compared to something like Cloudflare. Because
Hmm.
Cloudflare was supposed to be one of those things that was supposed to be, I don't know, bulletproof or whatever, or failure proof. Let's call it like this. Uh, the thing is that uh, when I think about all the services and people who uh, are using those services, uh, Azure is actually much better when you need to do something that is easy to describe.
Yes.
Because for some reason, AWS went so deep into the abstraction and into trying to separate all the services into the smallest possible little bits that it's sometimes complicated to just describe the architecture that you're trying to achieve. Uh, and then it's even worse when you try to actually achieve this architecture. Uh, Microsoft has a way, which is, from my perspective, also completely broken, but it has a way of actually getting the services together and not atomizing the services to such small places, as small pieces that you cannot use them as a, let's say, a reasonable whole.
Hmm.
So this is the thing. Um, when I try to do something, either in AWS or in the Microsoft, when I want to do something based on Linux, it's basically a toss. If I need to do something on Linux, I can do it on either platform, but it's easier to achieve a simple, let's say, couple of servers, a database, a DNS, outside IP address, and so on, when you're working in Azure, than it is when working AWS. Because AWS, for some reason, complicates things.
Yes.
And to make matters worse, there is also that fear that I have, and it's not completely unfounded, of AWS directly trying to confuse you into using different regions and then spending money on different regions,
Can
which is a big problem.
describe.
Um, for example, you just instance something in one region, then instance something in another region, and on the billing, you're just going to get the service name. You're not going to get the regions. So it's quite possible for you to get the, for example, I had a storage that I put up for doing something, whatever, and it stored some backups. And it was obviously in another region from the primary region that I was using for the services. And then when I discontinued the primary services, the storage just remained there. And it
Mhm.
took me a whole invoice to understand that, okay, now I have something stored that wasn't mentioned anywhere. I was completely sure that I'm not using any of the services anymore, but I had the data stored in another region, which wasn't mentioned anywhere. Because
Mhm.
you need to actually be in the region to see that you are using services in that region. And this
Excellent.
is one of those things that makes deploying things complicated. But this is not the thing that I wanted to talk about. The lunacy of people completely committing to Amazon, and then Amazon being, let's say, uh, uh, um, insane enough to not commit to being actually failure proof.
Mhm.
Let's say both you and me know that it is quite possible to create a database that would be let's I'm not going to say completely fail safe, but it would be able to withstand this problem.
Okay.
So I don't understand how AWS came into this state of mind, and what happened to other people. Because I think that there is a lot of complacency in the DevOps world, because everybody is dependent on everybody else doing the high availability stuff, and now we realize that nobody's actually doing it.
I have a stupid question.
Yes.
I'm fully aware that it's stupid as hell, but I'm still going to ask that. What does a database have to do with DNS?
The database itself went offline because the DNS lost the record for the database.
So it's the other way around. Okay.
Yes.
This
So the
makes sense.
DNS lost the pointer or the name of the database itself. So all the services lost API endpoints. And the database itself, from what I read, was actually online and working. But none of the API calls came to it.
So it was just like the shit that happened with Facebook a couple of years ago with
Yes,
BGP
but okay.
and everything.
But this was that one was much more fun.
That was but basically the same principle. Everything inside worked. It's just that for that in that situation, BGP, which then turned to also roll out to the DNS problem. This time it was just pure DNS.
But I think that the core problem is that both of those services or both of those failures actually meant were the result of internal DNS being the only DNS for the entirety of the infrastructure.
Mm-hmm.
Because Facebook was using internal DNS for everything. So when the BGP broke, they lost complete control over DNS, or the DNS weren't available for anybody. And also the same thing happened to AWS. When the internal services or everybody who was inside the cloud lost contact with the DNS, or the DNS got propagated in a way that it lost records for the DynamoDB, then everything else fell down like dominoes. But the thing is that why?
You know, I remember doing design of certain database clusters. It was a while ago, let's say 10 years ago or so. Also, I did quite a few Exchange database availability group deployments. And in some of the older versions of those applications, it was actually recommended for some of the DNS entries to be, how should I put this, done in a fail-safe way. Read that from a perspective of just freaking put down the DNS entries in the hosts file and forget about it.
Okay, but
For internal purposes, especially now that I'm thinking about it many moons afterwards, this makes perfect sense.
The only reason why they're not doing this is because they want to be able to scale up and down. But even if you take this into account, even using something as primitive as an Ansible playbook, you could actually solve this problem. So what I would like to see is how this system is going to behave the next time it breaks, because it's inevitable. Something is going to break inevitably. DNS is going to break for any of the services, which I must say that there is one thing. Microsoft actually didn't lose DNS and didn't have a problem with DNS in a long time. For some reason, they are able to, when they're shooting themselves in the foot, they're doing it
higher level.
On the high level. The last time it was when they were rotating the certificates. So they broke the certification rollout service for some reason. But they are not doing so many stupid mistakes. And it is incredible from my perspective that people know the DNS is going to break. They know that they're dependent on, maybe, I'm going to on a limb here, under 100 DNS entries when it comes to service. Okay, I know that there is a lot of round robin involved. There is a lot of different IP addresses assigned to the same service, and so on, load balancing and so on. But it could be that something will break, and that you can actually depend on having a single IP address hard coded into your service?
Hmm. Back into 2020, when COVID era started, one of the things that I did a lot of was on one hand it was education about AVI Network's load balancer, and on the other hand was actually implementing AVI load balancer in vast majority was VMware based environments because VMware bought it. There's a reason why I'm saying this story. It's not to promote VMware or something. There is a punchline there. I used many different types of load balancers before that, layer 4, layer 7, whatever. We played all through the past 10 plus, 15 plus years with, AJ proxies and Nginxes of the world to do a variety of different types of load balancing like applications. But what struck me back then was the way in which many corporate entities use load balancers. And one of the things that Avi and many and F5 and Netscaler and others have as well is a very well thought out monitoring service. When I'm saying monitoring service, in the case of their architectures, we're talking about the backend monitoring, which can be, TCP, UCP, UDP. It can be active, it can be passive, it can even be scripted, which is a huge plus. So basically, you can kind of like ping the backend server in the pool that you're load balancing, get a response, and based on that, the load balancer decides whether or not it is going to load balance and reverse proxy to your server. There is a way of doing this for DNS as well. That's my point.
But the thing is that I would like to see the post-mortem analysis of the whole fiasco that happened, because I actually want to know what the root cause is. Was
And
it a
I'm
bad?
I'm and I don't want to gloat about this. This is not funny.
No. But I want to know what the root cause is. Was it misconfiguration,
Mhm.
or was it that somebody actually forgot what they're doing and just simply wiped the configuration from some of the from one of the DNS servers? Because this is the only obvious reason that I can think of. How do you lose a single entry in a DNS table? Either you break down a complete DNS and then push the DNS to production, which is not fine, but okay. But in order to push misconfigured records into production, you need to change some of the records and then leave the rest of those available, because otherwise the zone propagation won't work. You cannot
Yeah,
just
it's a
delete the
strange one.
DNS.
Yeah.
Yeah.
And
So yes, go on.
actually, to go a little bit further than that, a lot of the most used DNS servers on the net still use bind. And there's a reason for that. If you wanted to do something like this in bind, you would have to try very hard.
Yes, I know. This is the point I'm making, and I don't know if they are using any internally developed DNSs, because I highly doubt it.
Okay,
Bind has been around for years and years.
30
It
plus
works.
years. Yeah.
Yes, it works. We know how it works. We know how it fails. So it's a known problem, if there is a problem. But the thing is that I don't know what I would need to do to make this thing happen if I wanted to. I would need to reset a zone and push that zone to a DNS, and then let the DNS distribute it all around. But at the same time, I would need to keep the headers correct.
Hmm.
Otherwise, it wouldn't work.
Yeah.
So you cannot just wipe a piece of a table, like usually happens with the BGP, and then say, okay, this is going to cause problems, because it won't. Bind is just going to give up on you and tell you that configuration is not correct. Go away.
Hmm.
And this is one of those things. But even if we don't know, or whatever is happening with the DNS, what I actually want to know is what happened to all the other DevOps guys. Why are we still relying on having a single point of failure? Even being it one cloud, we have so many possible services that you can use. But just from the top of my head, if we wanted to do something like this, and if you are pushing beds, you are not dealing with millions of beds. You're probably dealing with tens of thousands of users, if that much. You could create a small redundant server in Hetzner, whatever, on a service that is not dependent on AWS on any other service. And this would be a wise thing to do, especially if you want to, for some reason, and you can quote me on this. I found that there was analysis that said that a bed is sending something like 20 gigabytes of data each night about what person is doing while they sleep.
Okay.
So you're parsing a huge amount of data for some reason or the other, because you're trying to do some machine learning on how people behave when they're sleeping, which completely is completely off by any standards that I have, because I don't know what I would collect that would take gigabytes of data during the night.
Hmm.
And okay, let's ignore this thing for a second. But why not have a redundant server for a simple service like this, or Wordle? The Wordle broke, so people couldn't find their 5-letter words. Uh, but how?
I mean,
Why are you not redundant?
from the perspective of DNS as a service, if for a second, if we focus on this, without going through a major overhaul of what DNS is, there are ways in which you can make sure that this doesn't happen or that it doesn't happen as easy. So, just as an example, if we're talking about public facing DNS, so a publicly available domain that should be resolvable, if you use at least two, let's say, independent authoritative DNS providers like Cloudflare plus Route 53 plus or Akamai or something, configure them with separate infrastructure. If you use low TTLs for faster failover, if you uh, don't put much faith into vendor locking into a single region like this was, this is not exactly, this is not super difficult to configure actually. Should be standard configuration in situations like this, even without going to some, let's say, higher levels of intelligence in terms of, check ping if it works, if it doesn't, fail over, do this, update DNS records, push the updates faster, whatever type of DevOps we could theoretically think of. This is what surprises me to no end, that in the year 2025 that this is even possible. Just like you said, why is this possible? How is this possible? It's just incredible. I don't know.
The thing is that any design should take into consideration that anything can fail.
Yes.
And this was a failure of the DNS. Okay. Primary database was not available. Okay. Obviously, something happened that disabled the services that all the other services were relying on. Okay. Probably CloudFront. But let some of the services failed. What I'm missing here is, why are services that are not huge, like Wordle, like 8 hours or whatever, the beds, why are they relying on a single provider in the cloud? I wouldn't do it. You wouldn't do it. Anybody who is sane enough wouldn't do it. Is it the complacency? Is it the if something breaks, Amazon is going to be responsible for it, so we don't care, because
Hmm.
we are going to just keep pointing the finger to Amazon and say we didn't do it, Amazon did it? Or is it just complete laziness of design in the design, which says, okay, if I have a single cloud, I'm not going to care about anything else?
I think it's just the overwhelming complacency and blind faith in the cloud, if I can be critical. Because contrary to what people think, cloud is complex. It's not easy. It's not simple. It's not user friendly. It's not many things that it should be, and that it promised to be many moons ago when the proliferation started. Designing cloud services tends to be more complex than designing on-site services because of the codependency, because of the requirements that should be basically defined, as you said, multi-cloud type of environments. If you're going that way from the get-go, and I fail to see the reason why the all of these that we mentioned, all of the brands, all of the everybody's that failed, how can they afford this? Because this is like a limitless damage to their reputation, in a sense. Of course, people in the US went insane. It's not surprising whatsoever at the end of the day, because those are many hundreds of billions of dollars or whatever, data centers and services all over the world distributed, which should have no scope to fail like this, but yet they always do. And this actually further fuels what I'm teaching people when we do the high availability class in the graduate program, which is that I always tell them that in like vast majority of the use cases, 99.99% of the use cases, 100% availability is not achievable, and we should plan for that. We should.
Yes, this is the point that I was trying to make also, because you actually went right into the thing that I was trying to talk about. There is no 100% availability available. The such thing does not exist.
No,
Uh,
there is, but on the fringes of everything and not available to the end users.
no, but when you consider a single service, 100% is usually not available.
Hmm.
What you can do is you can split your services and you can make sure that even if you have 90% availability, you can fail over to something else.
Yeah.
And this is the idea of the architecture, because if I can have a service that is going to give me 100% availability, I don't need to plan for anything. I'm
Hmm.
just going to rely on the service to be there, and that's it. I sent you
Yeah.
postmortem because I was trying to find something about this, and actually the postmortem is online. I haven't seen it yesterday. I was looking for it today, and I actually found it. And the thing is that they are trying to explain that their own automated services published incorrect empty DNS records.
Hmm.
But the thing is that they are trying to explain that there is an empty record for the regional endpoint, which is fine. It could happen. But why is the regional endpoint for a single DynamoDB database responsible for everything else in the AWS world?
Because there needs to be some kind of an admin instance of something.
Okay,
Maybe it's
but
some kind of an admin instance of it that was basically, forced to fail because of it or something like that. I don't know. Just speculating.
yes. So this is the thing. So this is a complicated thing, and trying to explain how cloud is complicated is like trying to explain how to draw Mona Lisa.
Yes.
You are actually trying to explain something that is so complicated that most of the people that created that cloud are not completely sure into. People, I know people who are deep into specific technologies like cloud, like CPUs and so on, which uh, when it comes to some of the pieces of the technology that they're working with, just say, okay, this is black magic. We are not going to go into details because we don't know the details anymore.
Do you want my honest opinion why this
Yes,
happens and keeps on happening, and it's going to keep on happening?
it's going to get worse
Yes, I'm sure.
because specialization is going to get worse.
Correct. This is a systemic problem of, and I'm not harping on my on our drum. I've seen this over the years, and I think I deserve like a second of a time to explain this. This is a direct result of the fact that we are not teaching people how to do shit properly. That's the first thing. The topic that we are discussing is basically how to design a reliable computer system. I had a pretty complex course on the PhD study program about this, in which at the end, when I was taking the exam, the professor told me, You obviously know much more about this than I do. So just present you the paper, the seminar that you did, and let's get on with it." I took the liberty of reading a couple of seminal books related to the topic of reliable computer systems. Actually, now that I think of it, funnily enough, and I think I mentioned this to you, I had a chance to review a couple of papers in one of the very prominent scientific journals afterwards, in which people were talking about the improvement of the design of the IT systems without mentioning these two seminal books. And I got to say, when I saw that they were not on the reference list, I only prejudged that the papers are not going to be good. And it turned out that they weren't. So we lack, it's just like talking to young people about what are their role models. It's exactly the same discussion. The first book, which is from Daniel Sievorek and Robert Schwartz, called The Reliable Computer Systems. And the second one, which is even worse than that one, because this one is newer, the first one, is from Jean-Claude Geoffroy and Gilles Motet. This was actually issued by Springer, so one of the biggest publishers in the world, the book. And the last edition that I found was from 2002.
But the thing is that
And wait a
without
second.
quoting
Let,
the
let
books,
me
yes.
finish just one thing. The previous release of this book, I think, was from 1980s or something like that. People in the 1980s wrote everything there is about this. There is nothing new to add, believe it or not. There are design principles that have been with us forever, and they exist for a reason. And people need to be learning about them and not, be pronounced full stack programmers because they know two programming languages. I'm being metaphorical here. There is a huge skills gap in terms of what is required for services on this scale and what people actually do know. And recently, in some of the projects that I've been doing in the past 3 to 6 months, I've noticed this disconnect more and more.
The thing is that this disconnect has been always been there, and the
There's another
problem
book
is
that you told me about. I forgot what the name is. I have it
I'm
somewhere.
going to quote it now. So
Yeah.
my book that I always use as my go-to book that you actually need to know is called Systemantics.
Yes.
Systemantics: How Systems Work and Especially How They Fail by John Gall.
Yeah.
Um, it has turned 50 this year.
Yeah. I wonder why.
And the thing is that when it comes to understanding systems and when it comes to understanding things, the thing that we are usually forgetting about is that we are dealing with details instead of dealing with the bigger picture. And what is the usual failure in the modeling of everything that people are trying to create is the failure of actually creating a risk matrix that considers that everything can fail.
Correct.
Because what happens is when people are trying to create architecture, usually what they do is they try to consider all the services that are going to give them the easiest path to a solution.
Hmm.
So, and then they just assign a completely non-workable attribute like this service is going to be up 100% of the time. So we are going to use this for the whatever DNS or whatever. And then when the service fails to do something 100% of the time, everything else fails.
Yeah.
And the thing is that,
That's reverse design. That's not design.
but the thing is that people are doing the design this way because for some reason, all the IT professionals tend to consider huge things like AWS, Amazon, I'm sorry, Google, Azure, and so on as completely infallible
Hmm.
because everybody thinks in the back of their mind, okay, this thing is so huge that it cannot fail with a single point of failure. We are going to see the failure, we are going to be able to respond to the failure. So this is going to work.
Hmm.
And then something happens.
As it
Uh,
always does.
let's talk about the. Let me just find the article. South Korea. Um,
What, terabytes of lost data?
yes.
So
Can you do the introduction? I'm going to come up with the numbers.
I don't know if this was governmental data. I think it was. I don't know, some insane amount of gigabytes or terabytes of governmental data related to whatever was lost because they didn't have a backup.
858 terabytes.
Terabytes, excellent, and they lost it because they didn't have a backup.
It's not only that they didn't have a backup. What they created was they created a single point of failure, and this is complacency. What they did is that they created. From what I understand, a lot of the things that I read were translated from Korean, and they didn't make any sense when translated. But what I understood is this: they used a collocated Google Center. So basically, they had an instance of the Google Center there, but since they were using it as a governmental center, they didn't have a collocation for the center itself. So there was no redundancy because they said, okay, we are not going to create another government center, and we are not allowing the data to come to go out from the Korea.
Mm-hmm.
So there was no redundancy, and since then there was no redundancy, nobody was doing the backups for the disks. And what actually happened is that they lost something like 96 servers in the fire because there was a fire, and the backup was not existent.
Mm-hmm.
And people tend to think that if you upload something to the cloud, this is going to be forever there.
Mm-hmm.
And we know that this doesn't happen
Yeah,
because
people think that if they install a virtual machine in cloud, it's protected
yes,
and backed up. Not.
not only is not protected, it's explicitly not protected. Because if
Yeah,
you read the terms of services, when you put up a virtual machine, okay, it is going to be hidden in the Beware of the Leopard,
small print.
the cupboard. But the thing is that if you read the terms of the services, they're going to say that unless you are actually buying backup service and unless you actually provision multi-region service, you are not guaranteed anything, basically. And the thing
Correct.
is that right now we have come to a point where AI is going to make these things even worse.
Oh, come on, Mr. AI lover, you cannot say that.
No. Just give me a second. I'm trying looking for some things that happened in the past. So I remember something that I wanted to point out. So I need numbers. But the thing is this: when people are trying to depend on the services themselves,
Mm-hmm.
what they're doing is they are trying to make sure that the service itself works. But when AI came along,
Mm-hmm.
what happened is that a lot of the data centers that I know of started making room for AI machines.
Mm-hmm.
Specifically, they started making room for NVIDIA graphic cards and so on, or whatever the inference machines are called right now. And the problem is that they are much more power dense. So a lot of data centers don't have any more spare power available. So what is happening is that a lot of data centers that I know are running out of resources
Mm-hmm.
because they cannot create another set of resources that can be considered old servers, and people actually need those resources.
Mm-hmm.
If you need 1 petabyte of storage, you actually need storage. You don't need another AI solution for storage. You have to store actual reliable huge amounts of data, and
Mm-hmm.
this is a problem that we are creating. So uh, introducing AI into existing data centers means that you have to scale down your servers in your storages.
Okay.
And what is happening then is that you have a lot of AI capability available, but you don't have the place or the storage available to store all the data that you are creating. And this is going to become a problem because a lot of people are seeing a lot of money in AI resources, and they are scaling down all the other resources. So
Okay.
we are seeing a double whammy after the COVID era, because in the COVID era, a lot of data centers got over provisioned a lot,
Mm-hmm.
and this is why the pricing went up and so on. Now they are down provisioning because they don't want to be over provisioned, but also they are down provisioning because they want to make spare capacity for the power. And so we created basically data centers that are shrinking, AI is increasing, and people have expectation that the shrinking data centers are going to behave the same as they did before.
Well,
Now, let me
design
just
focuses. That's what it is.
yes. But the thing is that what I wanted to mention is also the things that happened with Google. Do you remember the? I cannot find the outage where they specifically deleted an account for the what's the pension fund or something.
Yeah, something like that. I remember that.
Yes, so they deleted an account.
Yeah,
So
not account, tenant.
no,
I
the
think.
account. The account was the problem. They deleted the account because the account then cascade deleted the tenant, all the backups, and all the multi-region deployments. And this
Oh,
is one of those
yeah.
things because if you delete something like this, and if the data center actually deletes your account, you are going to lose all the different things that are connected to your orchestration. So what is happening here is that you can have the best design running in the Google Cloud.
Mm-hmm.
If your account gets deleted, all the redundancy is going to go away because your account is not redundant.
Mm-hmm.
You are not going to create multiple accounts having the same infrastructure twice,
Mm-hmm.
because you are usually designing under the single account. So this is one of those problems where no amount of design is going to help you if the cloud provider is stupid enough.
It can be software bug. It doesn't have to be somebody from the cloud provider. But yes.
Yes, but the only way to stop this particular Google Cloud problem would be to have a completely separate hybrid or completely separate cloud solution on another provider with the same level of infrastructure that is going to be redundant. There is no
Okay.
other way to around it. And we are talking about probably tens, if not hundreds of millions of dollars in the infrastructure this here.
More like billions. But okay.
No, but the amount of money is 125 billion. But I sincerely doubt that the problem was the infrastructure itself is more than probably tens of millions of dollars. It runs in such a thing because they're mentioning something like hundreds of VMs and DR testing and so on. But this doesn't sound like too much of a deal when it comes to actual deployments.
Okay.
Anyways, I think that we have ranted enough about people depending on a single point of failure or creating a single point of failure by believing that cloud is not a single point of failure.
Cloud being be all end all solution.
Yes, but the thing is that I want to quote one thing from the Systemantics because I opened the book and I wanted to quote one thing from the Systemantics because it actually um, makes sense to talk about it. Let me just find it because there is a couple of things that the book considers first principle of system design.
Okay.
And the first principle that they quote, the very first principle, they call it a negative system design principle, which says, do it without a system if you can.
Okay.
And then after this, many functions are intrinsically unsuited to the system's approach.
Mm-hmm.
And then after that thing, systems are running the best when designed to run downhill.
A complex system that works is invariably found to have evolved from a simple system that worked.
Yes,
That's one of
the thing.
that's actually a quote from your book.
Yes and no, because the thing is that if you don't design a strict system, and if you expect that everything is going to fail, if you include the Murphy's Law into the system design, suddenly a failure is not going to surprise you.
Can
And
I
the only thing is that you need to have is a budget to cover it all.
can I try to sidestep this to a humorous end game related to AWS and then close the recording of the episode?
Okay.
AWS well architected, one of the books. Failures are normal, resilience is engineered. How about
Yes.
them apples?
Yes. 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 And the other thing is that for a quote from the book is basically what it said about the monitoring. Things are what they are reported to be,
Mm-hmm.
and this is the thing. They obviously lacked monitoring when you guys come to AWS.
Mm-hmm.
Because if you take a look at the postmortem that Amazon published, it took them 50 minutes to establish which part of the DNS failed.
That only means that they have a very reliable monitoring system, as I'm sure you
No, I
understand.
think that the problem is that they couldn't see the forest from the
From the
trees.
tree. Yeah, I
Yes,
agree.
and this is probably they had so many variables and so many monitoring monitoring things that they were keeping account of, that they couldn't find what the problem actually was. And also the other thing that is funny when you read the postmortem is that they say it took them half an hour to re-establish the core tools needed to unblock the search for the problem.
Mm-hmm.
And this means that you have a single system and you're depending on this system to work so that you can debug the same system.
Mm-hmm. Yeah,
Anyways,
I
let's
agree
finish
with
this
all of
thing.
those. I have many more, but we I think reached the end of the episode.
Because what we are seeing here, I see that you like my book, so
Yes,
you're
I do.
quoting.
What we've got
No,
here basically is a failure to communicate.
no. But the thing here is this. I just want to mention one thing from the book because I remembered something and I wanted this to be the last thing. Everything that works usually works in a failure mode,
Mm.
and the example that the book gives is completely unrelated to computers. They're talking about the garbage disposal system.
Yeah.
So they're talking about cleaning services that are covering a city. If you have something that is designed to have, I don't know, 100 trucks, 100 drivers collecting the garbage across the city, you are, if it's not the first month, you are almost guaranteed that you're going to have a broken truck, you're going to have a sick driver,
Employee. Mm.
you are going to have problems with acquiring fuel, acquiring oil, acquiring something. So parts of your system are going to fail,
Mm-hmm.
and they're going to remain failed for the entirety of the work process, because there is never going to be a period in which 100% of the trucks and 100% of the drivers are working.
Yes, there
And
might be if you plan for it.
yes, but then you plan for what is considered 100%.
Yes, correct.
And then when you realize that all the systems behave this way, you start to understand how the systems should be designed.
Correct.
Okay. Being that
Rent off.
being that for a couple of guys who are extremely tired, we did a good episode today. So I want to finish on the positive thought about let's go to sleep.
Yes. See you next
So
time.
thank you for being with us. Seeing you next time, and I do hope that both Vedra and me are going to be a little bit more less sleepy and more
You are sleepy. I'm
apprehensive.
not. I'm good.
Yes.
Woken up completely.
So see you.
Later. Bye.
Bye.